Welcome to Quarantine. In today's episode, we're going to be learning all about mushrooms and the incredible kingdom of fungi. And we have a math lesson about...
Remainders. We're going to talk about remainders and what's called modular arithmetic. It turns out remainders can be really fun, and it'll involve some clock arithmetic.
I am Science Mom. This is Math Dad. A special welcome to you if you're joining us for the first time or watching the replay. And I want to give a quick shout out to the people that I see watching us live in the chat. Hello to King Husky from Nebraska, Grace Gaming Wolf from Ohio, to Rishi from Virginia, Suganya from Oregon, Marine Man from Texas, Mama K from Pennsylvania, Owen from California, Vaniva from Missouri, Matthew from Colorado, Sravanti from Maryland, Alyssa from California, Zara from California, Aaron from Wisconsin. I'm seeing so many more go through our feed now. We're so happy to have you with us today. So to start out with, I have a quick question for you. And if you have seen the thumbnail, and I bet most of you have, then you know already that mushrooms are not plants. But I'm curious, how many of you thought mushrooms were plants before you saw that thumbnail? And just put a little P if you thought mushrooms were plants before, or put NP if you knew already that mushrooms were not plants. Because this is a common misconception.
I knew they were not plants.
Math Dad is very proud that he knew that mushrooms were not plants, but a lot of people think that mushrooms are plants. This is a very common. I'm seeing Lori and Cassandra and Matthew, several people writing NP. It looks like most of us knew that mushrooms were not plants, but I'm also seeing a few people saying, I thought mushrooms were plants.
Well, it kind of makes sense. They like grow out of the ground. It's nice and slow. I mean, to us, they seem to behave a lot like plants.
That's right. And they don't get up and move around like an animal does, right? An animal, whether it's a tiny little insect or something bigger like a snake or a guinea pig, an animal can get up and move. A plant can grow bigger, but it's not going to get up and walk around. And a mushroom is the same way. A mushroom can grow bigger, but it doesn't get up and walk around like an animal does. But mushrooms are not plants, not at all. And they're actually much more similar to animals than they are to plants.
Are you kidding?
No, I'm not kidding. Mushrooms are more similar to animals than plants. And to explain why, I prepared a cool little slideshow. So I'm going to share my screen with you because talking about fungi and how incredible fungi are, you really need some visuals because fungi are just amazing.
That's kind of crazy.
So first off, not a plant, much more similar. No, okay. You stay right here. You can watch with me, Math Dad. Right. Mushrooms are not plants, fungi are not plants, and they are actually the part you see that's the mushroom is actually just a small part of the fungus. So you can see here this nice little diagram, and all of the pictures that I'm showing you, almost all of them are from mushroomobserver.org, which is a fabulous site for identifying mushrooms or learning more about all types of fungi. And you can see that these fungi, this mushroom starts out by being just a little nub, and then it grows up and has that cap that we associate with mushrooms. But most of the fungus is actually underground. And here's what a fungus really looks like. So when we talk about mushrooms, we're actually only talking about the above ground part, the fruiting body. But if you have white mushrooms like the type that we eat growing on coffee grounds, that's what this picture on the one side is, it just looks like a bunch of hair. It looks kind of like mold, don't you think?
Yeah, I don't think it looks like an animal though.
No, it doesn't look like an animal. And when I say they're more similar to animals, I don't mean that they look more like animals, but that if you look at how the cells work and how it behaves, it definitely behaves more like an animal.
Okay.
Minus the getting up and moving around. So this is what a fungus is. It's a mass of cells, these long filaments, they're called mycelium. When you have all of these long filaments together, this is the main part of a fungus, and it's usually the biggest part, and the mushroom is a smaller part. But there's a lot of variety with how mushrooms can be. Now, before we get into the variety of mushrooms, I want to point out something kind of cool. So you've seen in the grocery store, you've seen white mushrooms, you've seen cremini mushrooms, and you've probably seen portobello mushrooms. Those are all the same species.
Really?
Really. Agaricus bisporus is the type of mushroom that we most commonly eat. And depending on how it's grown, it will be either white or brown. and then small or large. If you let them get really big and large and mature and they're big, then we call them portobello mushrooms. If they're small and brown, we call them cremini mushrooms. If they're small and white, we call them button mushrooms or white mushrooms. They're all the same species though, and you can grow them yourself in a box as long as you have some good organic matter that they can break down and eat, because mushrooms are decomposers. So most mushrooms, they eat dead material. So old leaves, rotting wood, they break down and eat things like that. Now, it's super important if you start getting into mushrooms and you think, oh, it would be really fun to go and pick mushrooms from the wild, or if you happen to see a white mushroom in the wild, I want to give you a very important warning. There are many mushrooms that are poisonous, and some of them are deadly poisonous. This one here on the side, the taller one, and Amanita bisporigera, it is called death cap, and it's so poisonous that if you eat one bite, you're dead. This other one, which has the common name of the vomiter, you may guess, is not quite as poisonous as the other one, but it looks a lot like the mushrooms that we eat in the store. And if you eat it, you will get sick, you will be throwing up. And it is not easy, especially for a beginner, it's not easy to tell the difference between these poisonous mushrooms and the edible mushrooms. Just because you find a mushroom outside that looks kind of white and looks similar to one you see in a grocery store, that does not mean you should eat it. So everyone in the chat, please say, I will not eat wild mushrooms, because this is a super important thing. Every single year, there are cases of people being poisoned by making mistakes when they try to identify wild mushrooms. So not worth the risk.
Well, that'd be a sad way to go. Yes, it's not worth it at all.
Not worth the risk. Now, those mushrooms, the button mushrooms, are not the only type that we eat. We also eat truffles. So the truffles are one of the most expensive foods, and it is a fungus. But it's a fungus that does not have the mushroom shape. They grow underground, and they're kind of like these little knobs, these little nobules. And then morels are another type of mushroom that people eat fairly often, and they don't look like a typical mushroom shape either. Turns out there is a lot of variety when it comes to fungi. You can see that for mushrooms, where you've got that stalk, and then up top, you've got that little flat head part, those mushrooms can be so many different colors, shapes, and sizes. And the whole purpose of the mushroom is to make spores. So a better name for a mushroom is actually a fruiting body. Fruiting body is what we typically call mushrooms and the other things that will make spores. And spores, that's how fungi reproduce. So they create these tiny little particles called spores, and you can think of them as being kind of like seeds, but there's some important differences between spores and seeds. And the spores travel out, and then they will germinate and grow into new fungi.
So they're just little like dust size.
Dust size. They're super, super small. So the stripes that you can see on the top of our mushroom cap here, those are the gills. And from the gills, you will have millions of spores produced.
Now, can a single spore turn into a mushroom, or does it take a lot of them?
Nope, single spore. A single spore can grow and become a new fungus. And then that fungus, once it gets big enough, it can create a new fruiting body, which usually for the fungi that we're most familiar with is a mushroom, but it can be very different.
Well, why don't they just take over the world then, if there are millions of them in each little mushroom?
Because fortunately, not every single spore germinates into a new fungus. If every spore, so this one on the far side, the Calvitia gigantea, that's a puffball. And you can see there's a huge difference between sizes of mushrooms. Some of them, like the ones on the left, are very, very small, but some of them can be enormous, and puffballs are huge. And puffballs produce trillions of spores. If the spores of one puffball all germinated and grew into a new puffball, they would actually outweigh the Earth. That's how numerous the spores are, and that's how small they are. Trillions upon trillions of spores from one puffball. Fortunately, not very many of them germinate and grow into puffballs. Puffballs are pretty cool.
Wow.
Now, some mushrooms look, this one on the left, it looks like a mushroom. You can still tell it's a mushroom. So some fruiting bodies are mushrooms, but some fruiting bodies of fungi are completely different. So look at this one on the right. It looks like a piece of coral.
Is that underwater?
Nope. That is on top of some leaves on a forest floor. And that is a fruiting body of a fungi. These are fruiting bodies of fungi too, but they look like cups with little tiny kind of spores and different things inside, so that then when rain drops on them, that splashes out and helps them to reproduce. And this one kind of looks like an upside down mushroom. But we also have brackets. Bracket fungi are like these big plates that sort of grow out of sides of logs. If you've ever gone hiking in a forest that's damp, you've probably seen these. They can be all sorts of different colors. And we also have really bizarre fruiting bodies that don't really look like anything else. So this one is sometimes called a peach fungus. I mean, look at that. Isn't that bizarre looking? And these, I mean, you can't make this stuff up. If I were to ask you to draw some sort of science fiction creature, you might draw something like this. These are all fruiting bodies of different fungi.
So pretty much anytime we can see the fungus, like that's always going to be the fruiting body?
Often. That's often when you see a fungus, what you're seeing is the fruiting body, but not always. There's certain types of rust that will infect plants, certain types of fungi that infect plants. And when they do, you'll actually see sort of the hyphae, and the hyphae is the threads that make up the big part of the fungus. Sometimes you'll see that kind of discoloring the leaf.
So when we see mold, is that a fungus?
Mold is a fungus, and when you see mold, sometimes you're seeing both. It all depends on how thick the mold is. Sometimes you're seeing the mycelium, you're seeing the main body of the fungus, but then if you look closely and you see these little kind of stalks sticking up, and with little knobs at the end, that's the fruiting body of the fungus.
Okay, so I'm just thinking like mold on old cheese
bread
or something.
Cheese.
Bread. So, and that just came from some spores from
It came from spores, yeah. And fungal spores are so tough. They are so hard to kill, they're so tough, and they're so abundant that no matter where you are, there are going to be some fungal spores. And so if you leave out a piece of something that has a food source like bread or cheese, if you leave it out, and if it's moist, fungi will start to grow on it. Always, always. Here are a couple other examples of just the variety of the fruiting bodies that you can see in the fungi kingdom. So you see this, this mushroom almost looks like some sort of strange sea anemone, right?
Yeah.
And then the one down here on the right sort of looks like whipped cream that someone, or the top of a meringue, like a meringue pie, but it's a type of puffball. And there's so much variety. So it begs the question, if all of these different things can be fungi, you can have a mushroom like on the left that has that beautiful lace-like netting. You can have slime molds like on the right, where it just looks like, it almost looks like someone vomited on top of this log, and it's just like, bleh, like this oozy stuff dripping down. These are both fungi. So what makes a fungi a fungi?
Okay, so they're not plants because they don't have like chlorophyll and all that.
Yes. So this is a big one. No photosynthesis. Fungi, mushrooms, they might actually glow in the dark. There are bioluminescent mushrooms, and they use the exact same chemical that fireflies use. Fireflies, when they flash at night, those little insects, they're using something called luciferin. And certain types of fungi actually produce luciferin and glow at night. They bioluminesce.
I thought those were jellyfish.
No, those are mushrooms. Those are mushrooms. And if you look up this type of, if you look up the scientific name for this type of bioluminescent mushroom, on the Wikipedia page, there's a nice little GIF someone did where they shine a flashlight on it and then take the flashlight off, and you can see it go from just regular brown to then the green as the light goes back and forth. It's really cool. But the big thing about mushrooms is they are not photosynthetic. They are what we call saprophytes or parasites. A saprophyte is something that eats something else that is dead. So like an old tree trunk or dead leaves or like rotten food, something that, has energy and maybe used to be part of something alive, but now it's dead. So decomposers, those are saprophytes. But fungi can also be parasites.
So that they're eating something that's living?
Yes, yes. So if you have ever had like toenail fungus or ringworm or a yeast infection, those are all health problems caused by fungi, because fungi can also infect living things.
And so fungus is singular and fungi
is plural.
You don't say funguses.
No, fungi. Okay. The other big thing that makes a fungus, or that distinguishes this type of animal, well, I didn't mean to say animal, critter, organism, that's the word I'm looking for, is that their cell walls are made of chitin. So I have cells. you have cells too. Do we have cell walls?
No.
No, animals do not have cell walls. Plants have cell walls, but plant cell walls are not made out of chitin. They are made out of cellulose. They're made out of like a starchy material. Chitin is a bit different and a bit tougher. And chitin is what makes up the cell wall of fungi, and it is also what makes the skeleton of insects.
Ooh.
Isn't that cool? So insects and fungi, there's that relation there that they both have structures that are made out of chitin. And cool fact, if you have ever gotten stitches before, you know that there are different types of stitches. Some stitches don't dissolve. You have to go through and actually pull them out later. Other stitches will dissolve, and so the top part where the knot is will just fall out of your skin after it's been, a couple weeks or so, once everything is healed. The first dissolving stitches were made out of chitin. Because chitin is something that we can break down. It's possible for us to break it down, but it's pretty tough. And if it's put together just right, it takes a couple of weeks for our body to be able to break it down, which is kind of perfect for stitches.
Oh, that's cool.
Isn't that cool?
Yeah.
Oh, and I did want to say too, so you can tell like so many bizarre shapes with different types of fungi, but not all fungi are molds where they grow into this big mass. Some fungi are single-celled, like yeast.
Oh.
So a fungi can be multi-celled or it can be single-celled. There's a lot of variety. And like we mentioned before, it can be a source of disease. There are infections you can get that will make you sick from a fungus, but it can also be a source of medicine. And the most famous example is penicillin. So penicillin is a blue type mold, and you have probably seen it before on rotten food. If you've ever had strawberries or oranges or fruit go bad in your fridge or on your counter, chances are pretty good that there's been a variety of penicillin that has helped that happen. And way back when, there was a scientist who was studying some bacteria, and mold contaminated his dish of bacteria, and then he realized that it had killed the bacteria. And he said, aha, this mold is making an antibiotic. Excuse me, it's making something that is killing the bacteria. This might be useful as medicine. And it turns out that penicillin was very useful as medicine, and it was the first antibiotic. But do you think
we just put it in our bloodstream and the bacteria the antibiotics?
To be clear, we're not just taking the mold, the entire mold, and putting that in our bloodstream. We're just taking that compound, penicillin, which is what the penicillin mold makes. And it makes it on purpose. This mold makes this antibiotic to kill bacteria, because when it moves in and it wants to eat, say this orange that's on the corner there that's starting to break down, and it's like, aha, there are sugars and there are proteins and there are carbohydrates. I will eat this delicious orange, and it starts to grow. Well, there are going to be bacteria that want to eat that orange too. And so the penicillin mold produces this compound that we have named penicillin. So it's a little confusing because the mold and the compound have the same name, but it makes penicillin, and that penicillin kills the bacteria. So then the fungus can eat the orange in peace without having to compete with bacteria. But not everybody can use penicillin as a medicine, because some people are allergic to penicillin. And that means that if they take penicillin, their immune system just puts out this like, mayday, mayday, we have a problem, and they'll have an allergic reaction.
So I assume there's other antibiotics that they can take?
There are a lot of different antibiotics.
Are all antibiotics from mold?
Not all are from mold, but the first was from mold. And fungi continue to be a source of new discoveries because they are so diverse, and there's so many different really interesting things that they make to survive and to adapt. They have really crazy digestive enzymes. They have, antimicrobial properties. They've got so many cool things that we can learn from. And the last thing I wanted to share about fungi, excuse me, sorry, is that
farmers?
They are farmers. So if you have ever seen lichen before, lichen is actually this really cool fungus that has captured algae, and they have a symbiotic relationship with the algae, where they have these little tiny photosynthetic algae cells inside their body, and they're like, okay, let's make out a deal. You do photosynthesis and give me some sugars, and then I'll give you these nutrients that you need, and I'll keep you from drying out. And that's what lichen is. Lichen is not a plant. It's actually a symbiotic relationship between fungus and these tiny little, cyanobacteria or algae cells. Isn't that cool?
That is crazy, and because it's all these different colors, so it's photosynthesizing though.
And depending on what type of cyanobacteria or what type of algae you have, you'll get different colors. And then, of course, the type of fungus determines the color as well. But yeah, algae, lichens are photosynthetic, but they're not photosynthetic because the fungus is doing photosynthesis. They are photosynthetic because the fungus has captured algae and is acting like a little algae farmer and has that inside.
Algae versus algae. I just keep saying it wrong.
So it kind of depends on like what side of the pond you're on. Like if you're in, the British say it different than Americans typically. And
okay, I didn't realize that.
And I flip flop. So yeah, algae. You can say both.
Nice.
All right. I want to pause our slideshow real quick. That's the last one for our fungi. But I do have some bird feeders that I want to show a little bit later. But let's do some Q&A. So great one here from Melissa. Bethany would like to know if mushrooms or fungi can grow underwater. It all depends. There are certain types of fungi that are aquatic, but I don't know of any that produce mushrooms. So there are certain types of single-celled fungi that are part of the cyanobacteria, like they're part of the, not cyanobacteria, plankton. They're part of the plankton that you see in the ocean. There are such a variety of single-celled organisms that live in the ocean and contribute to the whole plankton ecosystem. And some of those are fungi. But I don't know of any type of fungi that produces a fruiting body that looks like a mushroom underwater. But I do know that there are underwater fungi.
Yeah, well, just seeing how prolific they are, I'd be surprised if there weren't some, but yeah.
And the whole purpose of the mushroom is to let spores out, and then the spores kind of like float away and distribute. All right, a couple more questions.
All right, are mushrooms good for the garden or the grass?
Are mushrooms good for the garden or the grass? It all depends. It all depends. There are certain types of fairy rings, and if you look up fairy rings, you'll see pictures. Some fairy rings will actually, and it's just a large underground fungus that is circular in shape, and some of them will cause the grass to be a lot greener. So you'll just see this like bright green grass because they're breaking down and they're releasing nitrogen, and you're getting more nutrients, which is good for the plants. And others will actually kind of attack the plants, and you'll see a circle of brown instead, where you get the little mushrooms popping up. So it all depends on the fungus. There are certainly a lot of types of fungi that are very beneficial for plants, and there are a lot that we call things like rust or smut or mold or rot, root rot. There are a lot that will hurt plants too, so it just depends.
All right. Can mushrooms be poisonous to touch?
Can mushrooms be poisonous to touch? That is a great question. I do not believe so, but if you were allergic to mushrooms, you could have an allergic reaction just from touching them. So it kind of
I think the danger
depends.
would be more that you touched it and then later you're going to touch your face.
Yes. Yeah. If you touch one of like the death caps that are super poison, if you touch one of those and then lick your fingers, I think you could get quite sick. So.
Yeah. All right. Why are mushrooms different colors?
Why are mushrooms different colors? It all has to do with what type of compounds or what type of chemicals are in the mushrooms. So a lot of them, they have their color to sort of signal, kind of like this is my domain, I guess. But I'm actually not sure like what compounds cause what colors. That would be an interesting thing to look up.
All right.
Sorry. Some mushrooms, did you know that some mushrooms actually produce a bad smell on purpose to attract flies as pollinators? And pollinators isn't quite the right word because they're not producing pollen like a plant does, but they want their spores to be spread around. And so they'll on purpose, they'll make a mushroom that smells like a stinky, rotten thing. So then the flies will come, the flies will get the spores, and then the flies will spread the spores around. All right, go ahead.
That's pretty cool. Didn't know about that. All right, can fungal spores live in space, outer space?
Fungal spores are incredibly tough, and I think they actually can be completely dried out, desiccated, radiated, and then they can, once they get into a nice environment again, I think they can come back to life. Not all of them, certainly, but I think some of them are that tough.
Wow, I'm sure the answer was no. Okay. Can fungi eat each other?
Can fungi eat each other? Yes. Yes, there are some types of fungi that are actually specialized at attacking other type of fungi.
Do you have a favorite type of mushroom?
Oh my goodness. Do I have
Christine
a
wants to know.
favorite type of mushroom? I have to say, I think the ones that glow in the dark are really awesome. Yeah, those are probably some of my favorites. I just discovered them recently when I was putting together the slideshow, and I was like, whoa, bioluminescent fungi, I had no idea. Those are probably my current favorites.
I'm actually kind of curious whether you guys like mushrooms or not. Our kids we've had a hard time getting them to try mushrooms. And when I was a kid, I didn't like them so much.
So let's do a quick poll, because my half-sister cannot stand mushrooms, and she's not a picky eater. She'll eat just about anything, but mushrooms, she says, taste like dirt. She can't stand how they taste. I love mushrooms.
Type D for delicious and Y for yucky.
Yes. So let's type Y for yucky. Well, but then Y means yes too.
No.
Okay.
D for delicious, Y for yucky. I made it simple.
Math Dad has spoken.
Yes.
So type D if you like mushrooms, and type Y if you think mushrooms are yucky. And I'm curious just what the general consensus will be of those who are watching live. I'm seeing quite a few people say that they love them. I'm seeing quite a few Ds and yums.
No, Y was for yucky.
Well, I saw.
Oh,
yeah,
you actually saw somebody write yum. All
yes.
right. All right.
And then I'm seeing quite a few not like. But if I had to guess, I would say, I would say we're about 60-40, 60% liking mushrooms and 40% not liking. Although now I'm seeing a couple more Ys.
Okay, so it's not clear cut. Yeah, I have grown to like them very much. And a lot of flavor in there, but interesting. Is there anywhere where fungi can't grow?
If it's too wet, most fungi cannot grow in an environment that is too dry. So if the drier the environment is, the less fungi you'll see. In fact, if you do the classic bread mold experiment, you've probably seen this before. Like you take several pieces of plain bread, and some of them you touch, with hands that were not washed. Some of them you wash your hands first and you touch the bread, and then you put them into plastic bags. Well, if you just put them into plastic bags and you don't add any water at all, you'll seal up those bags, and then your bread will look like it's mummified bread. It will stay the same for a long time. We're talking weeks and weeks, and you see no mold. But if you put a little piece of like an orange peel in there, or an orange slice, or if you just even squirt the bread with, a couple squirts of water before you put it in and then seal it, if you increase the moisture a bit, then you'll see a lot of mold. So
if you don't wash your hand first, or do you see more mold?
I've seen it done several times where, yes, if you don't wash your hands, excuse me, sorry. If you don't wash your hands and handle the bread, then you'll get more mold growth on there than you will if you wash your hands. Because when you wash your hands, you're not just removing bacteria, you're also removing mold spores. There are spores of mold everywhere. Then they don't germinate until they find a good environment.
Yeah, I usually don't think of mold being a problem, or I better wash my hands, I've got mold on. I'm always thinking bacteria or dirt or things, but yeah.
Yeah.
Interesting.
Mold spores are everywhere.
All right. I think we got through most of the questions I had
Okay. Well,
forwarded.
And now I have some fact or fiction questions for Math Dad.
Okay, I'm ready.
You ready for this?
Bring it on.
A portobello mushroom contains more potassium than a banana.
Well, I've never heard the advice, hey, you need more potassium, go eat portobello mushrooms. It's always, go eat a banana. Oh boy, banana. What does the chat think? Chat, ew, that's what they said.
We're just slightly delayed. And I saw a couple people asking in the chat if I'm sick. I'm not sick. I think there's something about like talking nonstop in the morning for a half hour. And because it's like right in the morning, right when I wake up, I'm always having to clear my throat. And I wish that wasn't the case. But yeah, I'm not sick at all right now.
All right, I'm going with the chat here. They say true.
It is true. So portobello mushrooms are quite large. And especially, if you're cooking them down and you're comparing cooked portobello mushrooms to just sliced bananas, mushrooms in general will have slightly more potassium. But if it's not cooked, because they lose a lot of water when they're cooked, if you're just looking at like a single piece of mushroom versus a single piece of banana, the banana will have slightly more potassium. But a portobello mushroom is so big that it has more potassium than a banana typically.
Wow.
Yep.
Oh, pretty cool.
Pretty cool, huh? There are more than 30 species of mushrooms that glow in the dark.
Well, you showed us some, so I know the number is greater than 0. And I guess one of the other questions I'd seen in the chat was just how many species of fungi are there? But I'm getting the idea there's a lot. So 30 sounds totally realistic. Chat agrees this is true.
It is true. There are more than 30 species that bioluminesce. And in terms of numbers of species of mushrooms, thousands. So there are tens of thousands of different species of fungi. And yeah, so much variety. Number 3,
okay.
Bread is not toxic. Sorry, bread mold. Bread mold is not toxic. Hopefully your bread is not toxic either. Bread mold is not toxic. If you don't mind the taste, it's just fine to eat moldy bread.
Oh. Ooh. What a terrible question. Oh, I'm hoping the answer is false here. I don't want to, yeah, Joe. I mean, a little bit of mold, okay, you're going to get by. I don't want to be too picky, but a lot of mold and bread, just don't put the blame on me for not eating this stuff. Okay, chat. This is kind of saying false, or leaning towards false. All right, this is false.
It is false. It is false. So here's the thing with mold. It all depends on what type of mold you're talking about. There are a lot of different types of mold. Now, with something hard, like a hard block of cheese, you can cut off the part that's moldy, and the mycelium, you know, that thread-like body of the fungus, it won't be able to penetrate very deep. So you just cut off the top. You can eat cheese that has mold on it. That's perfectly safe as long as you just cut off the mold. But bread is very porous, and there's a lot of space in it, and it's spongy. It's easier for the mycelium to get into it. So once you see bread start to get moldy, you actually should throw the whole entire loaf away. I mean, if you want to be careful and try and cut out everything that you can see, you can. But it's not good to eat bread mold. There are certain types of mold that grow on bread that can actually make you very sick. So you could eat moldy bread, and then you could end up having vomiting and diarrhea later on and being really sick because of that mold. There are several types of bread mold that produce toxins that can make you sick, and long-term exposure to those toxins can cause other problems. So do not eat moldy bread.
Got a joke here from our crazy boy. What room can you not enter?
A mushroom.
A mushroom.
Why was the mushroom so popular at the party? He was a fun guy. I like it. He was a fun guy.
Very nice, crazy boy.
All right, last one. Mushrooms have a longer shelf life than most produce.
Oh, okay. So how long does most produce last? Usually a week or two at the most. So fungi, it makes sense that, you don't want it to dry out. Sounds entirely plausible. Is it going to get mold? It's already fungus, so I'm going to say true.
It's false.
What?
So fungi can go bad and spoil just like anything else, because there are types of fungi that can break down other fungi. So you can have, once mushrooms start to get kind of slimy in your fridge, that's a sign that they are starting to actually decompose. And once your mushrooms are starting to decompose, you don't want to be eating them, because then you're not just eating that fungus, you're eating other types of fungi or mold or bacteria that are growing on them. And apples and oranges, fruits that are actually designed to store energy and have something eat them, they'll actually last for a really long time. Like potatoes can last for 3 months in your fridge. An apple can last for more than a month. Mushrooms are only going to be about a week.
I was thinking about lettuce and stuff.
Well, lettuce and asparagus also don't last as long, but
I was exactly wrong. I was like, it's not like my fungus is going to get mold. But
your
okay.
mushrooms can get moldy.
I stand corrected.
Yep. Let me show you really quick what our art prompt and our engineering challenge is, and then we're going to go on to our cool math lesson. I want to make sure I give Math Dad some time for this math lesson because it's an awesome one. So our art prompt is to do a pointillism painting. Pointillism is a really cool type of art where you're just making dots, and then you're arranging those dots to actually create a picture. You can use markers, you can use crayons, you can use colored pencils, or anything you want, any material to do your pointillism painting. And then our engineering challenge is to make a rubber band powered car. And should we go ahead and show them the car that we made?
Yeah, might as well. So I just did a Google search, rubber band powered car, and a bunch of great videos popped up, and I kind of followed just one of the videos, and here's the result. And
you can totally raid your recycle bin and just use whatever materials you have on hand. You need something that will spin. You could use old DVDs or CDs. And then you need, oh, you're using my phone for a weight?
I didn't bring a book. What we saw was that my wheels would just spin.
So show them without first.
Okay, so I'll load it here. I'm going to start winding. And now if I let go, it didn't go anywhere. It turns out it just doesn't weigh enough.
All right. Now everyone say, hope Science Mom's phone is okay.
You don't like your phone anyway, right? This will give you an excuse to get a new one.
No.
Okay. Not a very good approach, but all right. And
I caught it before it rolled off the table.
Saved the day. Good job, Science Mom. So yeah, this one with just the thin rubber bands that we have on it right now, I easily roll 10 to 15 feet.
And I do want to show real fast some of the great work that came in last time. So we had these great bird feeders that people made just by raiding the recycle bin. So you can put one together with popsicle sticks. This one is a milk carton. And
do you think that scares the birds off to see the eyes looking out at it?
I don't think so, but I'm really curious. Really curious how to know more about how these did. Got paint cans on the side. I thought that was a real fun design. An old milk jug with holes cut in for the birds to get the seed. And then this one cut little holes in the side and then peeled it down so there's a platform. Aren't those great? Oh. And then one out of a water bottle.
Yeah, super slick.
Yeah.
I mean, all we did was take that old pine cone and tie it to a string with lots of seeds.
No, it's really fun to see what you can make by just raiding your recycle bin. There's lots of possibilities.
Indeed.
All right, Math Dad, let's talk about remainders.
Okay. If you want to try to look through the chat a little to get caught up, because you guys are saying lots today. All right. So when we talk about remainders, we're talking about, so when you divide, there's something left over, and often we care about the remainder a lot. So we have 3 kids, and by golly, when we get treats, we need to split them equally or one of the kids is unhappy. So what that means is that suppose we get 10 cookies, well, I guess since there are 5 of us in the family, we should probably each get 2. But often Science Mom doesn't need them, and I don't need the cookies. I don't need to put on the weight. So
I don't really like cookies.
Yeah. At any rate, so the kids are probably going to get the cookies is the way that it usually works out. Well, if there are 10 cookies and only 3 kids, well, I can only give each kid 3 cookies. So we're doing 10 divided by 3 is 3, but there's a remainder of 1. There's 1 cookie left over. Well, someone's got to eat that leftover cookie, and I can't give it to one of the kids. I need to eat that cookie. So I got to take one for the team. That's the way it works. But and actually this happens all the time with meals. Like they just don't make them in the right sizes for our family. So I end up eating, I wait to see who eats what, and I eat the leftovers. But the remainders is kind of the leftover piece.
That sounds kind of sad the way you just said it. I want to know that we feed Math Dad.
Oh yeah, I eat plenty. No worries there. But yeah, often it's the remainder that we care about. If I ask you, how many weeks are there in a year? Well, in that case, you would take the 365 days and 365 typical year, and we would divide by the number of days per week, which was 7. And 365 divided by 7, it works out to be 52. There are 52 weeks with a remainder of 1. So there's 52 weeks plus 1 day more. Well, sometimes we don't care. We care about the remainder more than we care about this number. So if I changed the question a little bit and I said, all right, 1 year from today, so today's a Monday, 1 year from today, what is today? May 18th, something like that?
Yeah, 18th.
May 18th. All right, what day of the year would May 18th be? Well, in that case, to figure that out, I can pay attention to this. I would go, 52 weeks plus 1 more, which would make it a Tuesday on May 18th. So when we do the days of the week, it just wraps around. We've got Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then it wraps around Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and it just wraps around over and over again. And what you're actually going to see is that the remainder terms are their own math system, and it works kind of like on a clock. And when I say kind of like, I mean pretty much exactly like on a clock. So on the face of a clock, try to draw in my numbers somewhat equally spaced here. All right, so you get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Oh, why did I start at 0? Just spoiler. All right. So usually the clocks have 12 on them. I don't know why. 0 is a better number. But okay. So when you look at your clock and you think, all right, 11 o'clock, well, on the face of a clock, what is 11 plus 2? The answer is 11 plus 2 is 1. Ooh. On the face of a clock, 11 plus 2 is 1. And it's a perfectly good number system. Well, isn't 11 plus 2 13? Yeah, but what we only care about is the remainder when you divide by 12. So what if you divide 13 by 12, the remainder would be 1. So this number system, anytime you're working with the clock, you're only working with remainders. Remainders when you've divided by 12. All right, so Science Mom, what's 9 plus 9 on the face of a clock?
Ooh, 9 plus 9. So 2, 3, 4, 5, 6, 7, 8, 9. It's 6.
Yes, 9 plus 9 on the face of a clock is indeed 6. Or you could have said, well, 9 plus 9 is 18. And 18, if you divide by 12, leaves a remainder of 6. So yeah, this arithmetic system is actually pretty cool. And cool fact, we can take the remainder before we add the numbers, or we can take the remainder after we add the numbers. So for example, let's pick some bigger numbers. What about 20 plus 20?
20 plus 20 is 40.
40. And on the face of a clock, where is 40? Well, we'd have to go around 1, 2, 3 times. That would be 36 hours. So 40 divided by 12 is 3, with the remainder of 4.
So you just get, 3 times 12 is 36, 37, 38, 39, 40, and that tells you a remainder of 4.
That's exactly right. So, or if we just counted 40 numbers, yeah, that would get us there. But what if instead we took the remainders before? So I said 20 plus 20. Well, what's 20 on the face of a clock? Well, 20, if I count all the way around, I will end up over at 8. So if I did 8 plus 8 on the face of a clock, I would also end up at 4. So yeah, you can take the remainder before you add or after. And usually you're going to want to pick whatever is the easiest, which means you probably want to do it before if the numbers get larger. But okay, let's look at some other properties here. So what happens if I add 12 to a number on the face of a clock?
You're gonna
12 plus 3.
You're going to get back to the same number.
3. 12 plus 7?
7.
7, yeah. Because every 12 hours we're back where we started. So the number 12 on a clock is really like a 0. In fact, we should have just called it 0 in the first place and not called it 12. Then we'd understand this even better. And now things are really matching up with remainders.
So I just got a text about the song. And I was thinking, because before you belt out the song, wait. I was thinking it might be fun to do like an echo. So how about we sing a line and then we point to the screen and we're silent and they sing a line.
Because they'll all participate. And I know they love this song.
Yes.
All right, here goes. I'm singing a song. I don't know the words to this song. Because I don't know the words to this song.
You just messed it up.
So they were singing that. So I was doing, I'm singing a song. I don't know the words. I don't know the words to this song. I'm singing it loud, I'm singing it loud. But I don't know the words to this song. No, I don't know the words to this song. Yeah.
I was thinking that I'm singing it loud and then you'd say I'm singing
it
loud.
You pointed too long. So,
oh, okay.
Yeah. The timing was off. Okay. All right. I mean, I don't know that we'll call that a success. But okay.
If you sang along with us, I hope you enjoyed that.
Okay. So let's try something. Can we do multiplication on the face of a clock? So on the face of a clock, 3 times 3, well, so just count 3 times, we get 9. Okay, that one was kind of boring. What about 9 times 9? Oh, so it means we count 9 numbers and we do it 9 times. Sounds a little crazy, but can we do it? Yes, we can. And so 9 times 9 would be 81. And 81, if you divide it by 12, so you're going to get 6 with a remainder of 9. Turns out 9 times 9 is 9. That one works out. Let me show you a cool secret here. An even easier way of doing that, the number 9 is like the number -3. 0, -1, -2, -3.
Ooh.
And -3 times -3 is 9. It works. Yeah, pretty cool that's doable. All right, so you can multiply numbers. You can add numbers on the face of a clock. Really cool number system. All right, here's an interesting property. Science Mom, if I take 2 numbers and I multiply them, so A times B equals 0, what do you know about A or B?
One of them is 0.
Yeah, if 2 numbers multiply to be 0, one of them has to be 0. That's just a property of the real numbers. But not on the face of a clock. Okay, so watch this. Science Mom, what is 3 times 4? On the face of a clock?
12.
Which is?
0.
3 times 4 is 0.
But neither 3 nor 4
neither 3 nor 4 is 0. So that's that zero product property that we take for granted when working with real numbers is not a property that all number systems have. So yeah, on the face of a clock, 3 times 4 is 0, but neither 3 nor 4 is 0. Okay,
Ooh.
So here, this whole time, we've been dividing by 12. Are there other clock number systems? Well, absolutely. For every positive number, we can make a clock out of it. So, for example, we could do 0, 1, 2, 3. So 0, 1, 2, 3, 4. So a clock with 5 numbers. A 5-hour clock, we might call this. Oops, 0. And on this one, it turns out it does have the zero product property. If you were to multiply 2 numbers here and you got 0, it turns out one of them had to be 0. That's the only possibility. So yeah, these clocks work out differently. So we're really familiar with the 12-hour clock. We're not so familiar with these other time clocks. I mean, maybe the 24-hour clock you might have more intuition on just because we have that many hours in the day, and that certainly follows the same trend, although we usually use the 12-hour clock to represent it. So you got, at least in the US, it's like, oh, we could use military time, like 1,400 hours. So 14 o'clock would be 2 o'clock on the face of a clock. Okay. So yeah, with these different number systems, you could ask lots of the same questions. Can you multiply? Can you add? And it turns out, yeah, you can do a lot of this stuff. That zero product property, sometimes it works, sometimes it doesn't. And you could explore a little bit and try to find out when it does and when it doesn't.
I want to ask real quick, are there any practical uses to this? Do you use clock math anywhere?
Yeah, all the time. So anytime you're working with remainders, you're working with clock math. So every time you tell time, when you look at the days of the week, pretty much any time where you have something that is repeating over and over, there's this secret modular arithmetic going on behind the scenes. So that's what they call this type of math, modular arithmetic. And it's not that hard to understand the basic computations. Although, so in my abstract algebra class, so this senior level upper division math class, we're still studying these same things. It gets a little more complicated and a little more formalized because we're trying to prove things. But absolutely, these show up anytime you have something that's repeating. And so let me redraw the 12 number clock here because I want to point out something. For the math mystery today, it's all about this clock. And got this question, and I could frame this different ways. We could talk about some critter that always jumps a certain number of dots, but I decided to use laser beams. So if I had some laser beam that always bounces forward by 5 numbers each time, then I can do this. 1, 2, 3, 4, 5. So, and one question that I might ask is, well, is this beam going to hit all the numbers on the clock? And I've got to say, at first glance, it's just not obvious. Is it going to hit them all? Will it miss some? That would require some exploration to try to figure it out. And so that is my exact math challenge. Would this hit all the numbers on the clock? And then what if we changed it so that instead of being just moving forward 5 numbers, what if it moved forward 4 numbers or 6 numbers or 7 numbers? And yeah, so I actually created a Desmos activity.
Woohoo!
Here's a code where you can explore this exact question. And I want to actually pull it up and take a look because I had a lot of fun making this guy. But
This is a pretty cool code.
yeah, let's see. So hopefully you can see it there. So yeah, whoops. Except that one's, I guess that one's showing the answer. All right. So, okay, I spoiled that answer. Turns out if it's always a jump size of 5, it will hit all the dots. All right. What if I change this though? What if it was a clock with like 22 numbers? Oh, okay, 21 numbers. Ooh, turns out if you take jumps of size 5, you're going to hit all the numbers. All right. What about if you take jumps of size 13? Well, it turns out that one hits them all. What if I took jumps of size 14?
Oh,
well, that one didn't work. All right. Ooh. What if there were 22 numbers and jumps of size 14? I missed half those dots. That didn't work.
There's something very satisfying about seeing that loop go around.
Yeah. And it all depends on the jump size. So sometimes the pattern looks cooler than others or has a lot more structure to it. And sometimes we're hitting all the dots. Sometimes we're not. So for the math challenge, I want you guys to try to determine how can you, if you were given a clock with n numbers around it, and the laser was always jumping forward by k numbers with each bounce, then will it hit all the numbers? How can you decide? So that's our math mystery for next time.
That sounds like a fun one.
But let's talk about the answer to our previous math mystery. Okay, so what was going on last time was we had this king standing in the center of the plane, and he had put up towers in the plane at all the points where there were integer coordinates. And the question was, which of the towers can the king see? Or which towers can the king not see? Because there was an enemy general who was trying to sneak in at night and knock down any towers that the king couldn't see. So let's take a second and circle these. So the king cannot see this one. It's going to be hidden from view. All right. We'll see. What else? Can the king see this guy? No, the king. Ooh, right here, the king cannot see that one. The king cannot see that one. The king cannot see this one because there's some tower in between. And then what we wanted to do was be able to figure out some rule that would let us know whether the king could see a specific number. So if we looked at the point, say 8, 15, so that means over 8 up 15, can the king see that? Turns out, yes, the king can see that. There's nothing obstructing his view. All right. But if we looked at instead 10, 15, that's also way up there. Turns out the king cannot see this one. Any guesses, Science Mom? As to how I know that the king can see this, but cannot see this one.
No. Oh, wait. These ones share a factor.
These ones share a common factor. Of course, every number, all numbers share 1 as a common factor. But yes, these ones share a common factor. So for example, the common factor of 5 here, if I divided by 5, we would have found the point 2, 3. This point
blocks that one.
Blocks that one, as well as all the multiples of this. So 2, 3, 4, 6, 6, 9, and 8, 12. All of those would block this one.
That is pretty cool.
So yeah, the king is only able to see a number a point if they don't share a common factor. So in other words, I think the way I phrased the question, the general is able to secretly destroy any towers where the points share a common factor.
Nice.
That's the answer to our math mystery. All right.
Real quick, I did see a couple questions in the chat about summer and like what is coming next. So let me throw this up real fast. This is our last full week of quarantine. We are going to have a holiday next Monday. There's going to be no live stream next Monday. And then 51 and 52 are our last episodes. And then afterwards, we are going to have a real fun game show. And how many days of game show we do depends entirely on how many questions are submitted. We want you guys to help us make the questions. So please, there's a link on the Patreon where you get the notes, and I'm going to post it to social media again today. So please submit questions so that we can have a couple days of game show.
And are those questions supposed to be about things that have been learned through
Yes.
via quarantine,
So
or
think
also
about,
just other questions, or what?
Think about some of the topics we covered, something that you learned that you thought was cool, and then write a multiple choice question and submit it in the form, and we'll do a fun game show review.
Oh, fun. All right. Do we have
I do have
what's
a
in the
riddle for
bag?
you.
A riddle
Yep.
for me. Okay.
I have 2 shoulders but no head.
Just like 2 shoulders, but no head. That's kind of weird. What has shoulders but no head?
Sometimes there's a fork in me.
Is it just a road?
Yes, good job,
Yeah,
Math Dad. And people sing songs about me.
On the road again, do
Do, do, do.
I can't wait to get on the road
There
again.
are actually a lot of songs with road in the title. I looked it up yesterday just for fun, and I was like, oh wow, there are a ton.
Country road, boom, boom,
Yep.
take me home.
And
Okay, so
hit
yeah,
the road,
the
Jack.
roads have shoulders and a fork in the road. Yeah, okay, that.
Yep. And shout out to Hannah and Jay Thomas Graham. I saw so many people saying road, and I am seeing several people asking. They're saying that version of the song didn't count. I have to say, if people have not heard the song before, they were probably so confused by that. Like,
Yeah.
what is going on?
That's true. That would be a letdown.
That they should look up. But I'm not saying you need to sing it again. I actually
What is that? I'm singing a song. I don't know the words. I don't know the words to this song. I'm singing it loud and I'm singing it long, but I don't know the words to this song. No, I don't know the words to this song.
What I was going to say is that there is an awesome video where our fans and our viewers sent in clips of them singing the song. So if you don't know the song, you should go watch that video. But then Math Dad sang it again.
Now they know.
Now they know.
The anticipation, the suspense was killing them. So.
All right. I want to answer just a couple questions, and then we will be all done. Quick reminder that our art prompt for today is pointillism, to create a picture just using points. And then, of course, our engineering challenge is to make a wind-up car. And that is what our art prompt and engineering challenge is for today. And then I did get a great question about water bears, and if water bears, if water bears lived in fungi. You remember water bears, tardigrades? Those tiny little miniature animals?
Okay, yeah, I have no idea.
Tardigrades are also super tough, and they're one of the few living things that can survive going into outer space and then come back. So just like mold spores can survive extreme temperatures and radiation, so can tardigrades, because they kind of go into this shriveled, dormant state. They don't typically live in mold, but they do like damp environments like moss, and that's an area where you would also have mold growth. So they could be living together, mold and tardigrades, but not like as a rule. So that was a good question. And then let's see. Another good question is plankton a type of fungi? So when we talk about plankton can actually refer to a lot of different single-celled organisms. And usually when we talk about plankton, we're talking about photosynthetic cells. But there are types of fungi that live in the ocean along with plankton. And whether they actually qualify as plankton or not, I would have to look up. And I'm thinking probably they don't. I think plankton just refers to photosynthetic cells. But there are single-celled fungi as well. So that was a good question. All right, another good question. Do eggs mold? Pretty much anything can mold. And here's the interesting thing about fungi. Fungi are so good at being decomposers, at taking other material and breaking it down, that they can digest so many different things. I'd say any type of food and any type of animal any type of organism that used to be alive, fungi are going to be able to break it down. So any type of food, fungi will be able to break it down. And there's currently some research on whether or not we can get fungi to break down plastic, because plastic is synthetic. It's not something that is made in nature. It's something that is man-made, and it's a really long polymer of these different units. And the way they're linked together, we haven't found things that break down plastic very well yet. But there is some promising research looking at fungi that can actually break down plastic.
What about hallucinations? Can mushrooms cause hallucinations?
Yes. There are several types of mushrooms. So we mentioned the death caps, which, one bite of a death cap mushroom and you die. They're incredibly poisonous, and they actually stop your cells from being able to function. But there are a lot of different types of fungi, and several types of mushrooms do have hallucinogenic properties, where if people eat those mushrooms, then they'll see things that are not real and that are not there. And that's kind of where the whole like mushroom in popular culture, where people, kind of the tripping out thing, that's where that comes from. It's a real basis in it. Yep.
Cool. Is there Painting with the Scientist today?
There is Painting with the Scientist today. And in Painting with the Scientist today, we are going to be talking about bananas, because there's actually a really cool story about the bananas that we used to eat that we don't eat anymore, the variety that we currently eat, and it all has to do with a fungus.
Mm-hmm.
Did you know that the bananas that we eat today, the Cavendish variety, is probably not going to be in grocery stores in another 10 years or so?
Really?
Yes.
Bananas.
But not to worry, because there will be replacement bananas. There are hundreds of different varieties of bananas. And also we may be able to like stop the problem. But there was a type of banana called the Gros Michel that everybody ate in the 1960s. And that was like the banana. But then a fungus infected that strain of bananas, and since their clones have wiped it all out, I'm totally like giving away the good story. I'm not going to give away the good story. Come watch Painting with the Scientist and you'll learn more. So thank you so much for joining us today. And we hope that you enjoyed learning more about fungi and about modular arithmetic. And we will see you tomorrow.